Hello, this is another video for Frames and Machines, and today in this video I'm going to be talking about the procedure of analysis and the free body diagrams and how important they are, and also how to inspect a frame and to get started on solving for different pieces of the frame or machine. So our procedure of analysis, and I went ahead and wrote these on there already. Our procedure of analysis to draw the free body diagram, and I like to draw the free body diagram for the whole frame. So for example, if I was to draw the free body diagram of this frame, I would go ahead and take off the fixed and the two rollers, and I would go ahead and add in my forces there. So I'd have the moment about A, I'd have AX, and I'd have AY. Now in this case we know that AX is going to be 0. I would also add CY, and EY. And that's what my free body diagram for the whole frame for this frame. For this frame, I would take off the pin connection here, and I would go ahead and write if that was AY, AX, and again here CY and CX. So those would be the free body diagrams of both frames, and that's the whole frame itself. So in this case, if I sum my moment about point A, I could solve for CX. If I sum my moment about point C, I could get AX, or sum my moment about A, get CX, and then sum my forces in the X, and I would have AX. So I would actually have two of the reaction forces on this frame, and this would be a given weight. So let's go ahead and draw the free body diagrams of each, and let's say that we have to compute the reaction forces at A, C, and E, and then on this one we have to compute the reaction forces at A and C. And we're just going to go over the procedure and how to inspect a frame to get going. So let's go ahead and take a look at this one up here. I'm going to draw the free body diagram of each section now. So I've already have the whole frame. Now let's just do of each section. So how I like to do this is I'll put them kind of together, and I'll put this last one, and then again I would draw every force that's on there, and we'd have one somewhere down here, and we'd have, let's not include AX because we know it's 0, so I'm just going to take that out, and the moment about A, and I'm going to go ahead and label these AY, CY, EY, and this was 12 kilonewtons. And then we have this force here, which was 3 kilonewtons per meter over 6 meters, which is going to be 6 times 3, which is going to be 18. It's going to be 18 kilonewtons. And we know that this distance here, so it's important to put your distances, this distance here was 2 meters. It's a meter. And this distance here was 4 meters. This distance here was 6 meters, and this was 3, and this little guy here was 3 meters as well. And we would know also, since that's sitting right in the middle, that those two distances would be each 3 meters. So now let's go ahead and input the forces. So let's say I'm going to have a force here and a force here. Again, because this is point D now. This is D. And this is also D, because all we did was explode this frame. So I took off D to E, so this would be D to E. B to D, which would be B to D. This actual point right here is C. And then this point here would be A, and this point here would be B. So by putting all these forces on there, now I have the free body diagrams of each one, except for the reaction forces at each point. or each, I shouldn't say point, I should say connection. So I'm just going to go ahead and draw these in. And what I'm going to do now is I'm going to go, alright, so this is going to be bx. Both of those are going to be bx. This is by. Both of these here are going to be dx, and this is going to be dy, and this is going to be dy. But now what we want to do is we want to show them opposite and equal. So if I say by, I'm going to go up. This one must go down. If this one goes out to the right, this one's got to go to the left. So you notice they are opposite, but yet equal. I'm going to do the same thing here. I'm going to go ahead and add this up, to the right, to the left, and down. So by inspection here, if I sub my moment about point D, I would get EY. Then once I do that, I could sum my forces in the y and I would have dy. So the only one that I wouldn't have is dx. But if I sum my forces in the x here, dx would be 0. So in case this here, if I sum my moment about point D, well, I already have dy from this, so I'd put in dy, so I could just sum my forces, or sum my moment about D. Actually, the better thing to do would be sum my moment about point B. I'd get cy. Sum my forces in the y, I'd get by, and so forth. So really, you can look at a frame once you broke it up, and look, can I sum a moment about a point, or an axis, or something, to get one of the unknowns. That's really by inspection is what we mean. If we started over here, we don't know AY and we don't know the moment about A. So we have two unknowns, really three unknowns because of BY. But if I start over here, work my way left, I could solve for all my unknowns. Now let's draw the free body diagram of this one here. And the reason I have this as with a dot there and this with not, because this from here to here, this is all one member. So if I exploded it, I would have, that's one member. Let's try that again. That would be one member, and that's going to be CB. CB. Then I can draw this whole member, which would be up here, like so. And we would know that this point is also point B. So we'll go ahead and label that in there. And then we're going to have, we'll call this point right here, we're going to call that E, point E. So we're going to call this point E. And then you would have all of your reaction forces on there. Like so. Now reaction forces are the same. So if the reaction forces on the whole frame look like this, I put them on the frame just as. So looking at this, I could also draw the reaction force, or the forces here. I could draw at B. I could draw something like this. And I could draw something like this. And I could call these both BC. And we know that this angle would be 45 because this, we'll call this distance 2 meters and this distance 2 meters. So all these were 2 meters. So if this was 2 meters, we would know that this is a 45-degree angle. Now, I still need to draw the free body diagram of this pulley system. So if I draw the free body diagram of this pulley system, I'm going to kind of draw it big, so kind of right in there. So this point in here is E. Now, with this force, this is a given force, and this is also a given force. We have those two forces acting on there. And if this weight, let's say, was 400 newtons, well, this would be 400 newtons. And we would know this would be 400 newtons. So what's happening right there at point E? Well, it's going to be opposite and equal of these forces. So this force would be going in at 400 newtons, and this here would be going at 400 newtons. So when we looked at EY, since at point E, this is point E, they'd be opposite and equal. So this would be 400 newtons, but notice it's going to the right, opposite and equal at point E, and this would be going down at 400 newtons. So I could also draw my force like here, but this is going down to the left, so this has got to go up and to the right. This would also be BC. So in this case, I could solve up here. I could say, okay, I can solve for pretty much everything up here. If I sum my moment about point A here, and now this was 2 meters and this was 2 meters, I could solve for BC. Once I have BC, I could sum my forces in the X, and I would be able to solve for AY and AX. Once I have all of this, I know BC is going this way, or up into this, that BC would be going down, this BC would be going up, and then using this BC, I could compute the forces in the Y and the forces in the X, and I could compute all this. Now realize that if I assume something, dx, dy, if I'm assuming this to the left, and it comes out negative, we know that it was going to the right. So this would also change and also go to the left. Remember, these are always opposite and equal. If dy became negative, that means this force would be going up into point D, but on this member it's going to be going down on point D. So I kind of hope this helps. I'm going to put a couple more examples online to clarify hopefully some questions that you guys have. Thanks.